So since 2019, you've been with Shining 3D, and I have to say, man, what a good time to join that company, because since 2019 to now, it is a totally different company. Is that fair to say?
Yes, it is. Because also I'm the witness of the entire great history of Shining 3D. I see the start of the boost of intraoral scanner, and that makes the company really great. Yes.
Hey guys, and welcome back to another episode of the Digital Dentistry Decoded podcast. Dr. Ahmad Al-Hassiny here from IDD. Now, it is a super exciting week for Shining 3D. They just announced a massive announcement that really has the opportunity to disrupt restorative 3D printing. And who better to talk to about this than the R&D manager of the 3D printing division at Shining 3D. Chen, thank you so much for joining me.
Thanks for having me, Dr. Ahmed. I'm pretty a pleasure to introduce our latest product to all of our clients. Yes.
Yeah, for sure, man. Now, before we jump in, I'd love to just hear a little bit about your history. How long have you been with the company? A bit about your background. I mean, you obviously know a thing or two about 3D printing. I'm sure we'd love to hear about it. Please let us know.
Yeah, I joined Shining 3D since 2019. So it's been 6 years I've been working with this company. So many models, we are working together with Shining 3D. Before Shining 3D, I was studying in the States, Virginia first, and then the Bay Area for a few years. And then I come back to Shining 3D.
That's incredible, man. And I love your name. I said it off record, and I'll just say it on record. Chen, that is like the best name ever. But okay, so since 2019, you've been with Shining 3D, and I have to say, man, what a good time to join that company, because since 2019 to now, it is a totally different company. Is that fair to say?
Yes, it is. Because also I'm the witness of the entire great history of Shining 3D. I see the start of the boost of intraoral scanner, and that makes the company really great. Yes.
Yeah, I mean, I don't think anyone can argue that the Elite, I'm a big fan. That product was just, I don't know, as close as a masterpiece as you would say in this new generation of scanners. I think it totally projected a company, a Chinese company especially, from just being seen as making cheaper products to actually being a market leader. And now, of course, you guys have this new 3D printer, which, I'm sure it's going to make waves. Please, let's talk about it, Chen. First, the name of the printer. What's the name? And if you could just give us a brief description about this printer and the thought process that went into it.
So the name of our printer is called Ceramix-Nano. Ceramix is a combination of two words. Cera means the ceramics. Mix means we can do the dynamics mixing and also fast printing during the process. So this is the name for our product. Nano, of course, it means tiny, very small. Basically, it's the smallest, most compact system in the market. I think we finished the task starting from the real need from our clients. So first of all, we know that this entire industry have been looking for having printers into the clinic. But honestly, space is so precious. We see many clients, they are reluctant to introduce the system into the clinic because of space. They're concerned that they have to need to do some change to the furniture and etc. And also the current system, we have printer, we have a washing system, we have the curing system, put them all above the table, it will take quite much of spaces. So starting from this basic need, we developed Nano. So we are asking ourselves, starting from the first principle thinking, not only copy another small printer. This is the interesting part. My supervisor, the entire R&D supervisor of Shining 3D, we are thinking with the logic and the feeling from intraoral scanning development. It's the core difference from our 3D printer. He asked me, if we are going to do a very compact chairside system, how large the system can be. I said, according to the past experience about the DMD projectors, it will be maybe a little bit smaller than our previous version cell. He think, no, think twice. We are developing intraoral scanners for decades. why don't you use projectors like similar size from intraoral scanners? I was totally speechless because I never think about the thing in this angle. So that's why, like from the very starting point, our thinking about developing the printer is different from all the other companies. We are actually borrowing the successful experience from the intraoral scanner.
That's incredible, man.
So then more and more, we are gathering the real need from our clients so that we have a not only small, but very powerful DLP projector inside the system. It's actually DLP. It's incredible.
It's like not just an intraoral scanner projector. This is a DLP printer.
Yes, it's a DLP printer, and the power is incredible.
I guess before you go on, Chen, for those listening, they may have not seen the announcement yet. I was fortunate, guys. I got to play around with this printer before schedule. It is kind of mind blowing. Basically, for those of you who may be listening, it's the size of an espresso machine, actually smaller. So, you know, those tiny Nespresso machines, not the big ones that you have in corporate offices, the ones that do the single capsules and no milk. This printer is smaller than that. When I saw it, I was kind of mind blown because this thing can fit anywhere. I mean, and I'll say it, you know, the Midas really shook the industry with 3D printing and restorative printing, but this thing is really tiny, and it's incredible to see a free market compete in this way. And this is why Chen is talking about how small it is. It's kind of crazy how you fit a DLP into this box.
Yeah, so the size, actually, when we took our printer to our beta tester is asking, did you forget to bring your printer with you? I said, it's in the pocket over here.
Amazing.
It's totally amazing. It's totally amazing. Yes.
That's incredible, man. Okay, so it does pod printing. And so obviously, I mean, before we get into the pods and all of that, because there's going to be a lot of questions about how it mixes and these things, I want to get into your head and the R&D department's head. Because, look, a lot of people will say, obviously, you took inspiration from other pod printers, etc. But I really want to understand, why did you make a pod printer? Do you really see as a company that this is the future of restorative printing? Do you see this as the future of restorative dentistry? Because I think now as a company, I mean, Shining 3D is in a unique position. They have the scanner, they have the design service, they have a AI design they're building. And if you have a very good restorative printer, I mean, this completes the circle. But do you truly believe in resin printing?
Yes, it's a great question. Thanks for asking. So I think I can share my experience with you. First of all, yes, I believe this will be the future of the photopolymer, and also I would say for dentistry, because there are scenarios that the nano system is really just remarkable. Like, for example, if during the chairside, we are treating a patient who need to do a crown with limited time. So like a real story happens. Let me introduce that to you. Like our beta tester from Japan, Dr. Takahashi, one day he was expecting to receive a crown from his lab, but unfortunately, his lab sent him the wrong crown. And then his patient is already sitting on the chair. So I think he got probably 20 minutes. Otherwise, he will probably disappoint the patient so much, and the patient have to go home. But within the 20 minutes, with our Shining Flow system, he finished the design. He finished the printing with our nano system and finished all the post-processing and successfully like treat the patient. I'm not saying that our chairside printing system will replace a lot of the existing process. It's not that case. I think in some good scenarios, I really hope that our product can be helpful and really be used by our clients. And this is our purpose. And also the nano system, because the way it's printing, I think this will give our material science, the entire industry, a better future. Will like relax the conditions of material, maybe allow it to be more viscous so that we can deliver better mechanical properties. So yes, I truly believe in this future, like after seeing so many stories. Yes.
And so, okay, let's get into the printing, because a lot of people are going to make the connection, right? They know the Midas, does press printing. What's the technology that you guys are using in your printer? So you have the capsules, you have the build platform in there. What exactly is going on? How does this pod printer work?
So the core idea is based on like to solve the problem. We want to print faster. We want the peeling force, like the layer separations to be more smooth. And also like for the future, we want to be more efficient about the usage of the material. Like all of these questions combined together lead us to a solution of pneumatic. I will just generally explain the process. Like for traditional printers, every layer you need to separate it from the film, right? The distance probably will take maybe more than 10 millimeters. But we don't want this to happen because the 10 millimeter, the travel time alone is already too long. And also it will make the system much larger. So we want to control the separation within 1 millimeter, like in this scale. So we figure out a method that during each layer, not only relying on the mechanical separation, but we borrow the idea of pneumatic stuff. The air will come into the capsule, like gently push the film off the printed layers so that it's separated. And this solves our problem, the previous three problems I introduced. So first of all, the printing speed, it's guaranteed because we are not traveling so long. The printing speed is really nice. And then the second thing is about the usage of the material. Like, for example, if we think about a hydraulic system, if you want to print some model in a cylinder, the hydraulic means no air in the system. You have to infill the entire cylinder fully, 100%. The larger you print, the more material you are going to lose. But if it's the pneumatic system, you only need to keep a very shallow layer of material down there. So not only the small capsule, it will be a lot of imaginations for the future systems as well. And lastly, I think about the size of the printer. Yes, it's guaranteed because we control the travel and etc. That's our idea. We want to introduce a brand new, like totally imaginative solution to the industry, want to contribute to the community. Yes.
Incredible, man. And a couple of interesting things that I saw when I was testing the printer is that it even does the mixing, which is quite cool. I see that you guys have
Yes.
identified things that, the Midas, you have to manually mix it. But you guys, the mixing is inbuilt in the machine. So you just have
Yes.
to put the capsule in and
Yes.
that's it.
Yes, we have a high requirement on ourselves. Like, we don't want to bother our clients to do any preparation before printing. Don't do those works. Otherwise, probably will take your time and also a lot of mistakes can happen. So that's why the ideal of the capsule is that our user take out the capsule and do some kind of simple registration and then just put it into the machine, directly use it. Don't do any like preparations. It's not necessary.
And the other cool thing is that you guys have built in the cure at the base of this tiny printing machine. Now, I'm going to say it. The first thing that came to my mind is how strong is this cure? Because one of the things that I've seen with other small printers that have a cure within the printer is that the cure doesn't seem to be, perfect, or it's not strong enough. I mean, why did you guys go through this process of putting the cure in the machine rather than have a standalone super high powered cure box?
Because it's also like with my supervisor, I really need to say many thanks. He challenged me a lot. Like I'm the guy with the basic thinking of like 3D printing guys, but he's thinking things from a totally different perspective. He's an expert in optics. So according to him, like, what is a curing box? Like, maybe to him it's just a few light bulbs. He challenged me, why can't you just integrate them together? Because think about it, if you integrate the printer and the curing, at least it will solve a lot of troubles for the users, like no more extra machines you need to buy. And also the entire clinic will be very clean and tidy. So the result, if we guarantee the quality, the result will be pretty nice, will be lovely. And then we talk about how to guarantee the quality. In the curing box with that tiny area, yes, of course, thanks to the printing area, because we are focusing on the printing space of up to 3-unit bridge, so the space is not too large. It means with the limited space, we can output hybrid wavelength and also very powerful light, like in this tiny space. And also, because the space is very definite over here, so we can heat up the space up to 80 degrees Celsius. I think with these two combined together, it's already the best curing solutions on the market. And also, later on, he challenged me again. Can you put the nitrogen thing inside? I think about it. Yes. So in the end, we have an accessory. I think Dr. Ahmed, you see the solution. We have an accessory of a tiny box, which we can do the inert gas curing. I think the candy coating is just accepted by the community. People love it. And we did a lot of testing, for example, the wear resistant testing, showing that candy coating is actually helpful. So we decided to introduce all of these into our system and still make them into one piece. Yes.
So from all your testing, I want to touch on that point because it's an interesting point. From all your testing, and you guys have one of the most impressive R&D departments probably in all of dentistry. What's the preferred way of post-processing in dentistry?
Mm-hmm.
Because there's a lot of candy
Mm-hmm.
coating, and I agree, I don't think it's the best option. I think it's just a solution that's temporary.
Mm-hmm.
But what is it? Is it glycerin? Is it nitrogen? Is it polish? Is it candy coating? In your expertise, what is the best post-processing solution?
So, because I'm R&D, so I tended to introduce everything with quantity. So we actually did a test internally in-house. The above method you mentioning, for example, the polishing and then the candy coating, or without the polishing, we actually have a wear-resistant testing machine out there, like running for already months. And the result shows for now, the candy coating, of course, with inert gas, it's necessary, shows the best wear resistance. And that's it. We put the crown on a toothbrush machine, like brushing a day and night. And the loss of weight, I think the candy coating just gives us the best result.
Wow.
Polishing is also good. Polishing is also good. Similarly.
Wow. And
Mhm.
speaking of, okay, so you're doing the print part, and what about the resin? Let's talk about the really key part of any printing, because I have to
Mhm.
say the form factor is incredible. The fact that you guys have created a printer this small is kind of mind blowing. But the reality
Mhm.
is 3D printing is all about the resins. This is why Sprint Ray has done so well, because they make some of the best resins in the industry. Why Packed Dent is so popular. And one thing that I've personally noticed in the market is that, especially with Chinese companies, they don't seem to be the biggest leaders in resins. I mean, Packed Dent has a lot of factories in China, but anyway, you know what I mean. So you have the hardware, you have the printers. Is the next big
Mhm.
focus for Shiny 3D going to be resin?
I will say that Shining 3D, because the gene or the DNA of ourselves, like we started becoming successful with the intraoral scanner. And now we have reached a milestone about the 3D printer. So yes, we are also like putting like very heavy investment on the development of resin. So for now, like when the nano system is releasing, we have a permanent restoration material, which is over 50% of a ceramic filling available on the FDA market. We are also actively and aggressively doing registration on the CE and also Japan, China, etc. So yes, this will be our first generation of material. It is wear resistant, but I have to be honest that after our beta tester do the real cases out of this material, we need to do better work. So for example, the challenges is one of the most obvious challenges is aesthetics. So most of the ceramic loading materials are not just, it's just not translucent enough. So we get that, and also our material scientist is thinking about that, and I think we already have a solution. So based on the first generation of material, we will have a new product coming very soon, like the translucent one. And also ultimately our user, if we are not talking about the technical stuff, like the chemical technical stuff, what they really want is a material that mimics the performance of a real teeth. We get that. So we're also working on that. I think we have a technical decision, and in the end, it will be maybe high ceramic loading, and at the same time, it will borrow the assistant of heating, etc. So stay tuned. I think Shiny 3D, we have really great opportunity over here, and also we are cherishing this opportunity to really change the industry. So we will have new products coming up very soon. Yeah, stay tuned.
Look, man, I have to say I give you all my respect, and frankly, I tip my hat off to you, because I've interviewed many people from different companies in dentistry, all from C-suite people to product engineers and everything, and it's very rare for someone from a company to acknowledge that, we know that this is some of the downsides of this product, but we are working on it. And I respect that
Yes.
approach so much. And, there's no shame in that. So obviously you have these resins and you're going to launch with it, and people who are excited and want to be early adopters, I highly recommend they try it. They just have to be realistic with the current limitations of the resin, and it's common, like you say, that translucency is a common issue. I'm curious to know, why is translucency such a problem? Because some materials can do it. Like I hate to keep saying Sprint Ray, but obviously they're one of the leaders in restorative. They have Crown
Mm-hmm.
HT, and I'm curious, why is
Mm-hmm.
why is translucency so difficult? Because you obviously have studied the wear resistance. You have this
Yes.
amazing machine. The form factor is incredible. The price is incredible.
Mm-hmm.
What is it
Mm-hmm.
about translucency with resins that makes it so difficult?
I will say this have something to do with the entire supply chain of the resin industry. So with high ceramic loading, like the core concept will be the powders inside, like you put into your resin. So talking about powders, we have multiple materials like glass, like SiO2, or the other materials, and also like they have different shapes, like round, random shape, like a cylindrical shape. So in the end, you will have a problem about the refraction, like light refraction rate matching with the resin. If they are not matching, then it will become opaque and not very transparent. So we are actively working with many like best suppliers across the world, looking for the best ceramic powders to put inside the resin. So I think the entire industry needs some time to achieve the best material. Like it's about the supply chain stuff.
Oh,
Yeah.
interesting. And so this new
Yeah.
resin that you're launching with the printer,
Mhm.
what's the name of this new resin?
The name of our resin is called LumiCera.
LumiCera. And how many shades?
5 shade in the beginning, but I think within like really fast time, we will have MT and HT ready for the market.
Amazing, amazing. And so currently, is it fair to say it's in LT at the moment?
Yes.
Okay. So it's
Yes.
a low translucency resin,
Yes. It's.
restorative resin, over 50% filler.
Mhm.
You guys say that you're
Mhm.
happy with the wear resistance. That's all really exciting stuff. And what's really your focus with this? Because, with 3D printing and restoratives, the industry went from very serious about printing crowns to now mainly talking about
Mhm.
inlays and onlays. That's the trend I have.
Yes.
What's the
Yes.
company's focus here? Is it to provide like a crown solution that's not Emax and zirconia? Is it to focus on inlays and
Mhm.
onlays? Is it to focus on veneers? What's really the ambition to make this machine?
Like Shining 3D. Let me introduce the way we work internally. Like I have weekly meetings sitting together with the R&D from intraoral scanner team, from the AI algorithm team, the cloud team, and also from material team, etc. So I think Shining, we are trying to really solve the problem like in dental industry. Like for example, we know that if we want to make our users' life easier, we need to, for example, the Chrome application, better to take care of the entire application from start to the end. Start means gathering the data of scanner. Like for example, like the scanner need to be really accurate. Now the crown and restoration is good. We are also working on the inlay, because inlay, if you want to like with high resolution detect the edges, it will be challenging. But Shining 3D, we are okay with this challenge. We are like working hard on it, and then transferring the data from the cloud system to AI design system. The AI design system will finish the different type of applications within minutes. And talking about applications, like AI, like it's not universal. Like sometimes we focus on application, we start with the posterior first, and right now the front teeth, and also like bridges, and also we are working on inlay only. So this process, actually we finish them like gradually, step by step, and in the end I think we can solve more problems. Okay, and the finish of the AI generation, then we go to the printer. The printer plus the material, we finish the work, and then we need a very good guide of user experience, meaning the post-processing. So Shining 3D, we are trying to give the value to the entire market with the word we call Shining Flow. It's not just one printer. It's not a machine. Like we don't want to give you a machine, and it doesn't mean anything. We truly hope that our doctors who work with us can be benefit from this process, like really solve the problem of them and tell us like what you need, and then Shining 3D will make the process even better. So it's not about only crown. Like in the future, we also have the jaw motion tracking. This will be introduced to other applications, and we will solve them from end to end, meaning that we will measure them, we will design them, we will make them. Yes.
It's incredible, man. You're inspiring me here, man. It's incredible. It's hard to imagine how some other scanning companies who only sell a scanner can compete in the future, because I totally agree. I believe, individual technology is being commoditized. There's really not a lot of interest in just a individual piece of technology in a clinic, but it's more so about workflow, the flow kind of system or ideology that you're designing. I want to tap into this
Mhm.
AI design piece that you mentioned, because you guys already have applications like, all the software and scan applications for design and temporary crown. But am I hearing this
Mhm.
correctly that, these flow workflows, this is gonna use AI design?
Yes. The AI design is already included in the workflow of Nano. When users receive Nano, the first thing they do, like of course, connect to Wi-Fi, right? And then we will have web page and app ready for them. So starting from that point, like in all the workflows, we are trying to switch the workflow from local desktop applications to the cloud. So later on, all the Shining users, when they receive the Nano, they will have credit of design, and then really like they can start to use the AI function of like restoration inlay. And we are also working on other possible applications for the future. We hope that we can solve the problem of implant crown as well.
It's incredible,
Yes.
man. That's incredible. And
Yeah.
so with this AI design, let's talk about finances for a second, because I'm sure people are thinking.
Mhm.
Let's start from the top. So the nano printer, how much does it cost, and what's the recommended retail price, let's say in the US?
For that, Dr. Ahmad, I think I'm the wrong guy to say. I'm
Oh
R&D, so
God, I got the wrong guy. Okay,
it's
okay. Let me.
it's more about the marketing team. Yeah.
Okay, sorry. Whoopsie. I got that
Yeah,
chin on the spot.
but I can but I can share with you some informations. So about the AI thing, for now, I think once you activate the machine, like in your account, you already have the credit to start the first few cases. And the more you use our capsule, like your account will accumulate more credits. So basically, I would say you're not pay for this.
Amazing. So if you buy
Yeah.
capsules, you get credits.
Yes. Every time you scan, you print, like after printing, you get extra credits. So meaning that your credits will never be depleted. Yeah.
It's incredible. But you can
Yeah.
use Exocad or something. If you design with a third-party software, you can use it with this printer.
Of course. Of course. Yes.
So and you can use this printer with any scanner, or it has to be Shining 3D?
We have an open system. So in our cloud system, you don't need to import the file from Shining's intraoral scanner only. You can import the upper and lower from the other files. It's working well. Yeah.
That's incredible, man. So with
Mhm.
the capsules, I could see that you could fit a crown, a couple of veneers, and even a bridge,
Mhm.
because the capsule looks quite tall, in volume.
Yes.
So you can fit
Hmm.
even a bridge vertically, it looks like. Is there plans for
Hmm.
other restorative printers of this nature, like arches or for dentures? Or is the ideology going to be, a large printer for all these other applications and a restorative printer for these simple applications like a single crown, inlay, onlay, bridge? What's the thinking there?
I'm glad you asked this. We are working on it, and we are thinking about maybe is it a good idea to have a other version of capsule machine? Like we really need some careful thinking. It's not only about changing the form of the 3D printing. Like of course, like based on the capsules, like we can make it small, large, but the true problem is it really going to be helpful for the entire industry? Like, will we make the doctor's life easier. So for now, I see some meaningful stuff over here. Like I see the pain of like traditional 3D printer users. If some doctors, they really like 3D printing, it meaning they have multiple materials. I see those doctors, they spend their valuable time just switching the tank and the material. Like I think over 30% of his time when he's standing in front of the machine, he's doing all the cleaning work. So yeah, from this point of view, like I think the large capsule, like it's really a direction which we need to think about. So that the core problem is we want to be helpful to our users, not really just creating something in a new shape, but it need to be meaningful. Yes.
That's interesting, man. One pain point that comes to my mind is post-processing, as you mentioned,
Mhm.
and I'm
Yes.
interested because
Mhm.
with this printer, you made the curing within the box. But what are you doing
Mhm.
about post-processing in terms of IPA? Because I still think this is a massive pain point that no one has really
Mhm.
solved. Is there any thinking about like the washing of these printed crowns? And I assume you're going to tell your users use a spray bottle because you can't dunk these highly ceramic filled resin crowns. But what's the workflow there? What are you guys thinking?
Yes, it's a great question. In the real cases, we have experienced certain scenarios that the doctor, in the end, he got something which is not as expected, right? The accuracy probably he think it's not fitting. So often I will suggest them, please try like the dye model before you cure it. So when he try that, like very often he will find out, yes, it fits. So what's the problem? It's about the intaglio, like it's not getting cleaned properly. And it's also like the pain point we have to solve. For now, like we have been trying many ideas, for example, the new solutions and also like centrifuge if possible, and also like a protocol of like a set of tool to clean that thoroughly. So it really it's going so deep with the material itself, like the high ceramic loading material. When it's get washed, it become chalky. Many people see that. So I think we will solve the problem by these directions, the formula of the material, like or using other external toolings to make it better. But yes, for now, I think we have to make the instruction very clear, like to guide our users through this process to clean it properly so that we can have a very predictable result.
Yeah, I guess this is the big missing piece that no one has seemed to have solved yet is the washing
Mhm.
of these materials and how to do it consistently because the issue is, you can tell one user to spray with a bottle, but how do you train an entire team to do this in the exact same way? I think that's one of the biggest issues right now.
Sometimes when we solve the problem, like we can solve it in a very hardcore way, or we can solve it in a smarter way. For example, this 3D printing industry, like Bamboo Lab, like honestly, they give contributions to the industry, making the machine or the progress like much easier to work. So that we are, as I mentioned, we are developing our own mobile app. Using the mobile app, we can easily do the registration. We can also like receive a lot of information about the instruction of each step. So it will be an interactive thing. Once our users receive the Nano, we will also have a app. So later on, when he want to check out like how to do each step, he can get access to the app very easily. And also, we are working hard on our user interface. Like after printing, we remind our users to do proper cleaning with video, like such things. So for now, the thing we need to do is really like to convey the information much easier and simpler. We don't want to waste our users' time to watch a video which is like 15 minutes long. So need to be concise and accurate.
And you see the main market for this is mainly like crowns, or what's the main kind of point that you guys are trying to bring this forward? Is it the messaging that you're going to bring to the market? Is it crowns? Is it veneers? Is it inlays, onlays? What's your main focus?
I would say for Nano, definitely crown, bridge up to 3 unit bridge, and inlay. Like we're still working on the veneer. But if anything, which is within the space of 3 tooth, like we will be able to solve it. So that's the concept of Nano, like a machine which is very small and can really help you, like Chairside.
It's incredible, man. I'm so curious to see how the response will be because, in a way, I think the market now is much more receptive to 3D printing resins than 2 or 3 years ago,
And
which is quite fascinating
uh-huh.
at the time you guys have entered the market because, you know, 2, 3
Mhm.
years ago, everyone was basically thinking this is crazy and resins, there's no chance we will use them for posterior crowns this way.
Mhm.
But now I
Mhm.
think the market is warming up to it. I still think there's a massive challenge on your hands. How do you convince
Yes.
doctors to stop using Emax and zirconia? What is your plan? Or maybe that is not your plan. Are you just trying to provide a lower cost alternative? Because how does this all work in your mind? You want more people to print resin crowns, but we already have materials
Mm.
like Emax and zirconia that are so established.
I will give you for example, when one doctor is doing some traditional restorations, the reason why he's doing traditional restoration is because he think the scanning of the preparation still maybe have a chance to make a mistake. And then the gap or the shape is not exactly what he want, right? So he prefer to rely on his own and then spend that 35 minutes to do the preparation, and the and patient need to sit on the chair for a long time. So this is how, like, where we want to solve these problems. We're not trying to replace anyone. We're just trying to find the problem, identify the problem, and solve it. In this case, if the shining flow, we manage to do the scanning well, we manage to do the design well, and in the end, we can deliver a much better result than composite, then I think it's already a large help for the industry. Like both doctor and the patient are saving time. So we want to really find the problems and solve them, not replace anyone. Yeah.
Yeah, man, that's incredible to be honest. Great answer. I guess my next question would be, so how do you get the AI design to be so good that even a new user who has no idea about design can use this printer? Because just like ChatGPT or any AI, you can put in inputs, but if you don't really understand the material, you don't know if the output is correct or incorrect or the AI is hallucinating. And the same with
Mhm.
AI CAD, we're seeing this where is your idea to train users how to know if a crown is correctly designed or if the contact point is correct or the embrasures? Because in a way, when dentists move 3D printing in-house, they also
Mhm.
adopt all the issues and challenges with manufacturing.
Yeah. So first of all, how to make our users like feel less pain when learning to use our AI system? I think the answer is in the interaction method. Like we are not just teaching our users how to use it. The all the teaching and learning stuff should happen in the interaction. Like for example, like internally we are trying to make the values, like many numbers, like these tables, less invisible. Like no one really know like
Yeah.
what the number is inside. So it need to be intuitive.
Wow.
Like if you choose the teeth, like better to choose things based on graphics, right? And then I would say the result verification, it's not just a work of AI, it's still like the shining flow concept. For example, like if during printing, we can have the crown and also say the die model coming out together, then you will definitely know what you are getting, right? So the intaglio, you will see like how accurate it is. But for the approximals, like many doctors, they have different preferences. Some doctor, they want it to be tight enough so that he got a chance to mill them down. But the other doctors, they want a little bit loose. So like when designing, we get that information so that we are recommending them a very good starting point to start with. And then we give them solutions to do the verification. Like, so starting from AI to the 3D printer, we work together to solve them, not just AI. Yeah.
It's amazing, man. I'm excited. I'm excited to test it out. I'm excited to see more. I mean, the printer is amazing, but I really am most excited about these workflows you guys are building, especially with the AI design, because I've been saying it for some time now. I think when AI CAD really becomes so foolproof, it will totally unlock 3D printing and maybe even milling in house. I still think the CAD is
Yeah.
not perfect. Most dentists are not going to learn ExaCAD, and the CAD solutions that exist now still are not total end-to-end one-click solutions. There's still steps, and you still need to understand what you're doing.
Yeah, of course, AI need a lot of training. So that's why we are starting from the accessible cases. For example, the crown. We focus on like really detailed technical aspect. Like for example, like our users, when they're using the printing of restoration of crowns, they will say, okay, let's start from like really detailed points. We don't want to add the support on the proximal surface or the occlusal surface. So like with this requirement, we will have thousands of models, which will need to go through some labeling, like to tell which is the surface of occlusal, which is the surface of proximal, and avoid them. And then we gather all these data and train them in our algorithm, so we have the result. I think it's all of these like tiny details which our user really want to make this thing like improve further and further.
And so with the printing itself, like let's say, okay, I have a, you called a Ceramix-Nano, right?
Yeah, Ceramix-Nano, yes.
Ceramix-Nano. I have a Ceramix-Nano right now in my practice. I scan with, let's say, a ALF or a Elite. I send it to this
Hmm.
AI design center that you guys run. It gives me a crown. I can check it on an app or something like that. I can send it to my printer. I can start the print process. I put a capsule in. With the print
Hmm.
process right now, let's say a single crown, what's the orientation of the supports? Is it on the buccal? Is it on the occlusal? What's kind of the setup right now?
So we actually are trying to tilt the crown a little bit so that the support will not be add too much onto the occlusal surface. Because if you avoid the occlusal surface with the support contact, the result will be much detailed. You will see many like tiny features on the crown, on the occlusal surface. That's what our clients need. And also like proximals, they don't want it to be over there. And so, yeah, I don't think we have much choices after these two like limitations. And also like about the intaglio, it's another thing. Like it will be the control of parameters to stop like overcuring inside. So with all these conditions in mind, I think we can deliver a repeatable and a reliable result.
And so the printing, let's say an average crown, let's say a molar, how long does it take with the Ceramix-Nano?
So for the anterior, the average time is 7 to 8 minutes. For posterior, around 9 to I think 11 minutes. When we are using the 3D printing, like the nano, like the experience will be much more real. One time, like few R&D of our team, the Intrascanner team, the cloud team, and the algorithm team, we're gathering together to discuss something. So we have a nano in front of us and start printing, like because we want to see the result. We haven't finished like too much conversation and it's already finished. Like we are amazed, like and that fast, like
Think.
yeah, so it's interesting. It changed many things in front of you. Like it's in the office, like with no smell. You just don't feel it exist. Yeah.
Yeah, I mean, this is the power of capsule printing and why it's been such a game changer. And it's incredible that dentistry is the industry it is, and we get so much changes and advancement. It really is incredible. So we're so lucky we're all in this industry. I want to go back to the printing for a second. So you
Okay.
print it, let's say a molar, 8 to 10 minutes. You take the molar out,
Mm-hmm.
you take the sprues off, you wash it, you spray
Mm-hmm.
it, make sure to clean the
Yeah.
intaglio, and then you put it in the cure
Mm-hmm.
box, which again, guys, is at the
Yes.
base of the printer. It's at the base, it's a little slider. You put it in, you click the LCD
Mhm.
screen to start the cure. How long does the cure take?
So we have two modes of curing. Like the regular curing is going to take 3 minutes. So in this 3 minutes, the chamber will be heated up to 80 degrees Celsius, like based on what material it is. And then we have really high intensity and also a mixture of wavelength to cure it for 3 minutes. That's the regular curing. And based on what customers needs, like if they want candy curing, then after the normal curing, they can put some thin layer of material on top of the crown. And then we have another jig, which is a transparent box. You can inject the inert gas, for example, carbon dioxide into the box. And then the aesthetics mode will take 15 seconds.
Wow, that's crazy. Okay. So basically, for a posterior crown, guys, 10 minutes to print, let's say on the high level. Let's assume the AI design to check it takes you a few minutes. wash it will be a few minutes, and then curing 3 minutes. So within 15 minutes, 20 minutes, you have a posterior crown.
Yes.
And you believe it, you will get this to the point where the resin is so good that dentists will be confident to use this instead of ceramic.
Yes. I would not say instead of ceramic. For example, like zirconia, it's been in the industry for many years. And also this material is working very hard on the mechanical property and also aesthetics. But in certain cases, for example, like restoration, if like your user is okay with composite, like this kind of treatment plans, then there is definitely a chance that 3D printing can be introduced to solve the problem in a more efficient way. And meanwhile, like the entire chemical industry or the resin industry need to evolve. We are trying to reach out the technical point that the resin will be somehow similar to the material of like real teeth. Yes.
It's incredible, man. I don't know what to say, Chen. So Shining 3D, you guys disrupted photogrammetry with the Elite. You kind of disrupted the intraoral scanner market with the ALF, which is crazy good value. And now we have this pod printer, which I don't know what to say, man. The company is doing incredible things. And it just must be a testament to your R&D department and the amazing team that you guys have there. It's incredible.
Yeah, thanks, Dr. Ahmad. Thanks.
Do you guys have any interest in milling machines, or that's not part of the discussion?
It's not that clear yet. The milling machine, we hope we can deliver something like, not Shining 3D. I think the next generation of milling machine will be more compact and also like more easy to use, right? And also, like we said, with the solution like a Nano have, it has to be more intuitive and intelligent, like having AI inside. So that's the real next generation milling machine the entire industry is waiting for.
Totally agree, man. I totally agree. Look, Chen, honestly, it's been a pleasure to speak to you. Do you have any last words for anyone listening, anyone watching? Do you have any last comments for the audience here?
I would say I'll thank our team first, and also my supervisor who always challenge me like with the new ideas, and also like a big fan to our clients. And without them like giving us like valuable feedbacks and also like new thinkings, I don't think we can finish this nano printer. And it is just the start of our team, and I think we will have more useful tool and also like materials coming out very soon. So stay tuned. And also thanks very much for Dr. Ahmad for having me today. It's a great honor to talk to you. Thank you.
Thank you, my man. Look, Chen, the honor is mine. You're honestly a gentleman. I really enjoyed this discussion together. I love how you take a very balanced approach to everything. And for those listening, look, it's just exciting, guys. Check it out. Ceramix-Nano printer by Shining 3D. I've spoke about this company a lot. In fact, back in 2019, I used to actually diss this company, and I said, their scanner wasn't very good, and, what is this company doing? And now to see how far they have come in 6 to 7 years is mind-blowing, guys. You guys all know about the Elite, you know about the ALF. We have this new printer now, super exciting product, and I'm excited to try it, and I really appreciate your time today, Chen. Thank you so much.
Thank you so much. Thank you.
And everyone, that's another episode of the Digital Dentistry Decoded podcast. Chen couldn't give us the pricing, but I'm going to get it to you. That's what I always do. So I'm going to write a blog about the Ceramix-Nano. All the pricing will be there. The price of the printer, the price of the cartridges, the price of everything, the credits. I'm sure dentists all around the world want to know, but also I'm sure the entire industry wants to know. Every 3D printer company wants to know about this. So I'll see you guys on the next episode of the Digital Dentistry Decoded podcast. Thanks for supporting us. Share this episode with your friends. Thanks again.